All right, 2.2, graphs of relations and functions. We're gonna graph lots of different things, and all we're doing is like making a table, giving the domain and range and telling if it's a function. So we're gonna make a table, that's how we're gonna get our points, or we're gonna just kind of know what it looks like on some of them, because that's a little easier. In Math Excel, they should set you up a table in most cases. All right, so here, we haven't learned parent graphs yet, so we should know that x squared makes a U-shaped graph called a parabola, but we don't know that in this class yet. We haven't learned that. So we'll just go with, we'll try -1, 0, and 1. Those are always my go-to. Let's plug those in first and see if we can get a shape. So -1 squared plus 1 is going to be 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. So -1, 2, 0, 1, 1, 2. And we have a U-shaped graph. Now we can do more points or less points. In Math Excel, you're graphing with a like graphing tool. And so as long as you get a couple of points and tell it what shape you're making, you're going to be fine. All right, so that's our graph. All right, so the domain is all real numbers. We can go all the way left, all the way right eventually as we go up. The range is going to start at 1 and then go up from there. So 1 to infinity. And we put a bracket on the 1 because there's a point at 1. All right, number 2, when we make a table here, y is what's having stuff done to it. So when we pick values, we're going to pick values for y. So we'll do -1, 0, and 1 for y. Plug those in and find some x's. So if I do -1 squared plus 3, that'll give me 4. 0 squared plus 3 will give me 3. 1 squared plus 3 will give me 4 again. So we've got 4, -1, 3, 0, and 4, +1. And again, it's got a square in it. It's quadratic. It should make a U. This one just makes a sideways U. That's still called a parabola, but it is not a function. And I forgot to say that over here. This guy is a function. This one that we just graphed is not a function. And his domain is restricted. It starts at 3 and goes to infinity. His range is all real numbers, because he goes up and down forever, but he starts at 3 and goes towards bigger numbers. All right, so these square root functions, you have to start with a number that's going to give you 0 under the radical. That's the easiest, and then go bigger from there. So if we think about what's under this radical, if we say that x is 1, then the square root of 1 minus 1, so the square root of 0, will give us 0. Then we're going to go bigger, and I want things that are easy to graph. So the next number I'm going to pick is 2, because I can do 2 minus 1, and that's a perfect square. And then the next number I'm going to pick is 5, because if I do 5 minus 1, then I'm taking the square root of 4, and I'll get a pretty answer of 2. Now you can do it and get decimals. I just would prefer to get numbers that work out. So 1, 0, 2, 1, and 5, 2. And then a square root function is going to be like half of a parabola. So it should always make like a little swoosh, like half of a U. All right, so this is a function. It passes the vertical line test. The domain is, let's start at 1 on the x and go forever. The range is, we'll start at 0 on the y and go up. All right, so again, number 4, we are going to plug in some y values. This one's a little easier to pick because it's just y under the radical. So I can take the square root of 0. I cannot take the square root of a negative. So we're going to start at 0. We're going to say the square root of 1 I can do, and the square root of 4 I can do, and then we'll see what our answers work out to be. So if we do this, we're going to get 2. If we do this, we're going to get -1. So plus 2 is 1. If we do this, we're going to get -2 plus 2 is 0. All right, so 2, 0, 1, 1, 0, 4. We know that it's going to make half of a parabola, so it's going to look something like that. This is also a function. The domain is going to go to the left, so start with -infinity and go up to 2. And then the range, we're going to start with 0 and go up from there. So that needs to be a bracket. 0 and then up, so to infinity. All right, so this is a cubic. This is a cube root. There are no real restrictions for those other than when you do the cube root, kind of knowing what numbers you can take the cube root of. But I would say let's just go with -1, 0, and 1 when you have a cube. So if we do -1 cubed, you're going to get -1, add 2, so you get +1. 0 cubed is 0, add 2, you get 2. 1 cubed is 1, add 2, you get 3. So -1, 1, 0, 2, and 1, 3. All right, so the problem here is that looks like a line, and we know that it can't make a line. So let's go ahead and do a 2. So if we do 2, 2 cubed is 8, plus 2 is 10. So our next one's going to come way up here to 10. So we know this has to go like this. And then same thing, if you do -2, you're going to have -8 when you cube that, and then add 2, so -6. So then -2, -6, and we look like this. All right, so anytime you do a cube, it should make this shape. All right, so you can get away with only doing a few points if you know what shape it makes. But again, MathXL is going to kind of set you up with what table they want you to fill values in, I believe, for the most part. All right, so here I can take the cube root of 0. So if I plug in a 1, we'll be doing the cube root of 1 minus 1, or the cube root of 0. I can take the cube root of -8, or I can take the cube root of -1 for that matter. So let's do that. So if we do the cube root of -1 minus, nope, that should be a 0, my fault. 0 minus 1, then we're taking the cube root of -1. So plug in 0, we get -1. If I plug in a 2, it'll be the cube root of 2 minus 1, or the cube root of 1, so I'll get 1. So again, we're going to have 0, -1, 1, 0, 2, 1, and it looks like a line. But you know that if you keep going, the next thing I can take the cube root of is like, what, 8? So if I do the cube root of 9 minus 1, so that I'm doing the cube root of 8 to get 2, that means I plugged in a 9 and I got 2. So we have to go way out to 9 before we can come up to 2. So we know that this is going to level off, and then this is going to level off this way. So again, 2 to the third is going to make this up and down squiggle. Cube root's going to make a sideways squiggle. All right, both of these are functions, and both of them go forever in both directions. So they both have a domain and a range of all real numbers. Now, when it comes to doing this on a test, we're going to have better plans as we move through some of the lessons. So, yes, you're going to have to make a table of some sort on a test. So make sure you're capable of doing that. All right, absolute value, hopefully we know, makes a V-shaped graph. You can plug in whatever you want. You just need to make sure that you end up with a V. So if you stick with like -1, 0, and 1 and you don't get a V, then you got to go farther. So the trick is, if I can start with what's going to make 0 then I can go either side of that, and that's going to give me a V shape every time. So if I start with x is 5, so that I'm doing absolute value of 5 minus 5, so I get 0, then that's like the vertex of the absolute value. And then I can just go with a number smaller and a number bigger. So we're going to plug in a 4, we're going to plug in a 6. Absolute value of 4 minus 5, absolute value of negative 1 is 1. Absolute value of 6 minus 5, so absolute value of positive 1 is 1. So then 4, 1, 5, 0, 6, 1. And then absolute value makes a V. If you'll just remember that, it makes your life easier. The next lesson is parent functions, so you'll get what each graph looks like. You need to make sure that you have an idea of what it should look like when you see different things. It'll make life easier. All right, so this is a function. It has a domain of all real numbers because it goes left and right forever. It has a range of 0 to infinity because 0 is the lowest it goes on the y, and it goes up forever. All right, so number 8, we're going to plug in y values, and we're going to center on 0 because y is all that's in there. So remember, we want 0, and then we can do like negative 1 and 1. So absolute value of negative 1 is 1, minus 3 is negative 2. Absolute value of 0 is 0, minus 3 is negative 3. Absolute value of positive 1 is 1, minus 3 is negative 2. So then we have these 3 points, and so we turn sideways because y is what's having stuff done to it. And that's why I plugged in y values, is because y is what's having stuff done to it. So this one is not a function. The domain is negative 3 to infinity. And the range is all real numbers. So again, domain is left to right. So the farthest left we go on the x is negative 3, and then it goes to positives from there. And then we go up and down forever. So all real numbers for the range. All right, so these last two are semicircles. So if you have the square roots and then you have a square, then you have a semicircle. So if you think about if we had x squared plus y squared is equal to 4, and I tried to solve it for y, I would subtract the x squared and take the square root of both sides. So this is the equation of a circle. This is another way of writing the equation of a circle. This is a semicircle because it's only one piece. It's the positive and the negative together make up a circle. This only gave us the positive, so we're going to have the top half. So we should graph the top part of a circle. All right, but everything else kind of works the same way. They're only going to give you ones that are centered at 0, 0, so we don't have to really worry about that. And then the radius is the square root of that number. So in this case, it would be 2. So start at 0, 0, and then you're going to go out, left, right, and up because it's the top, and make a semicircle. All right, so this one would be the bottom of your semicircle. And again, they're only going to give you one centered at 0, 0. They're not going to give you like extra parentheses and things like that. And then the radius is going to be the square root of 9, so 3. So for this one, we go out 3 and down 3, and we just draw that half of the circle. All right, both of these are functions. If they give you one that's x equals, then it would be one side or the other of the circle, and they would not be functions. All right, so domain, we go from negative 2 to 2. Range, we go from 0 to 2. So 0 to 2. All right, over here, domain is negative 3 to 3. And the range is negative 3 up to 0. All right. Let's make this bigger. There we go. All right, so this last part is I want domain, range, and intervals where it's increasing, decreasing, and constant. All right, this will be on your test, and it's slightly different from what you've learned in the past. I don't really know why this book um, insists on doing it the way that it does. I don't really agree with it, but that's what you have to do to get the points. So for increasing, decreasing, and constant, we always use a bracket if they're for the numbers. And I think it should be a parenthesis, and that's what you were taught in Algebra 2. But this textbook, this Math Excel, they want it to be brackets. So that's what we'll use. All right, so we will look at domain. So left, right is all real numbers. Range is bottom to top. So bottom is negative infinity and it tops out at 3. Increasing, if you trace the picture, it goes up and then it goes down. So this function is increasing and then it is decreasing. So for constant, you will write none or just draw a line. Don't leave it blank on a test, like write none or draw a line saying there's nothing there, not applicable something. For increasing, we have to do x values. From what x value to what x value do the y's go up? So the y's are going up from negative infinity up to 2. So from negative infinity to 2, we are increasing. And then from there, it starts going down. So from 2 to infinity. All right, number 12 is a line. So its domain and range are both all real numbers. It is increasing because it goes up from left to right the whole time. So from negative infinity to infinity. It does not decrease and it is not constant. All right, 13, domain. This is an open circle. Make sure you look carefully. So the domain is parenthesis 0 to 6 with a bracket. The range is -4. There's a point there. So bracket up to -1. And it's open here, but it's closed here. So it gets used. So bracket. We are increasing from here to infinity. No, not infinity, because this thing is closed. From here to here, we are going up. So we're increasing from 3 to 6. From 0 to 3, we are decreasing. If you trace it from left to right, it goes down from 0 to 3. And it goes up from 3 to 6. And it is not constant. All right, 14. I know I'm going fast. Remember, you're watching a video. You can pause, rewind, whatever. I'm just trying to make the video not be an hour long. All right, so left to right, it goes forever. Up, down, or down, up. From the bottom to the top, it goes from 0, and then it eventually will go to infinity. It just slowly goes there. It is increasing on this piece, so from 0 to infinity. This piece is decreasing. Remember, we trace it from left to right, it's going down. So from negative infinity to 0. And again, this one is not constant. All right, these last two, finally, we get something that has a constant piece. All right, domain. We go from -2 to 5. Range, we go from 1 to 4. We are increasing on this little chunk. So this is down, up, flat. So on the part where it's going up, so from 1 to 2. And then the part where it's going down, so from -2 to 1, it is decreasing. -2 to 1. And then it is a constant in this part where it's flat, so from 2 to 5. All right, so for this next one, for domain, I'm going to say let's put arrows on this. So from -infinity to infinity for domain and range. And then they have this already color coded. So we'll say it's increasing. The green piece is what's going up. And that happens from 2 to infinity. Then decreasing actually doesn't happen. It's also this red piece is also increasing. This red piece, it's going up. So it would be just a comma. And then it's also increasing from -infinity up to -3. So then for decreasing, we have none. And then the constant part is in the middle from -3 to 2. I don't know if the order that these are written in matters, but it's one comma the other. I know that part for sure in Math Excel. I would do it from left to right, so I would switch these in Math Excel just to make sure that they don't tell me I'm wrong when technically I am. Correct. All right, so that's it for that. You've got a test over these last few sections coming up, so make sure you get those Math Excels done. Let me know if you have questions.